Well, good morning, everybody. Great to see all of you here. Looks like you're all here. Good. So, this morning I'd like to give you a progress report on some things that I've been working on. And I need to begin with an apology. I have nothing to show you. Nothing works yet, nothing's finished, there's nothing for you to read, nothing for you to get, nothing to do. Sorry, it's still really early in the project. And the worst thing is, if this is interesting to you, at the moment there is no way that you can participate. And it's inexcusable. My excuse is that I was invited to speak on anything of interest to me. And this is really interesting to me, and I hope it'll be interesting to you too. So I'm going to be talking about the web. You've all heard of the web. It has transformed the world in some good ways and some bad ways. It's an amazing thing. And it's where we're living now, right? A lot of this stuff is happening there. And I have big problems with the security of the web, because more and more of our lives are being transacted on the web, and the web was not designed to be doing this. We're moving a lot of money. Key elements of people's lives are in the web, and the web is not safe for that. And I've been worrying about that for years and talking about it for years, and now I'm going to try to do something about it. So we can look at the state of security, or a metaphor for understanding that is passwords. We can look at the history of passwords in computing systems. The original computers, the first generations of computers, did not have passwords. Even though they were doing very important work, they were doing classified work, they were doing code breaking and designing weapon systems and top secret stuff. But the machines had no passwords. They depended solely on physical security. You had to get past the people with the guns in order to get close to the computer. That changes with the invention of the disk drive. With the disk drive, we now have online storage that's available to the computer. And it means that any program has access to everything that's on the disk. But that starts to become problematic, especially when we move into time sharing, where people are sharing a mainframe. And there can be lots of users, each with their own accounts, working on their own data. Their data needs to be kept separate from everybody else's data. So that's when passwords start to become important. But the passwords do two things. One is they keep one user from looking at another user's stuff, and the other is to make sure that nobody gets onto the system without paying for it. Two really important purposes. And passwords work for that purpose because generally you will only have one time-sharing account, so you only need to remember one password. People can do that. But if they don't work in the web today, because every site you go to, you should have a different unique password, and people cannot remember that many. And also, it turns out it's much too easy to trick someone into giving up their password. And so any system which is big and distributed, which relies on passwords, simply doesn't work. So we need to figure out a better way. This RFC 1738 is the RFC that came out of ITF, which first described URLs. URLs were an important milestone on the net. And in that document, there was a description of a convention for URLs in which you could have a password in the URL. You could give a username and a password. And that would get sent in the clear to the host, which was not safe at all. And in the RFC, one of the authors of the RFC understood that this was a problem, and so he inserted this sentence: the use of URLs containing passwords that should be secret is clearly unwise, which was an amazing bit of understatement, because it's much worse than unwise. And people actually used it anyway, and quickly learned why it was so unwise. So even though one of the authors recognized that it wasn't wise, they did not have a better alternative. And that's sort of where we've been for a while. So in order to look at what is, or how we can fix the web, we have to look honestly at what's wrong with the web. We have to look at each of the major components and say, well, how is this contributing to the difficulty we're seeing? And this analysis will be shocking and upsetting to some of you. You've never known anything other than the web, and to have someone come up and show you how this thing is not what you deserve, that may be a problem, but we have to do that. And the problems with the web, from my perspective, are its insecurity. And its insecurity are due to its complexity. Now, originally the web won over the other hypertext systems because of its amazing simplicity. Unfortunately, in the years, web standards can't ever fix things. They just add more and more, and it grows so big that it becomes very complex, and all of that complexity undermines its own security. And that's not something that's easy to correct, because you can't remove things from an open standard. So let's look at the components. First, there's HTTP, the Hypertext Transport Protocol. In my view, it does three things for us. The first is it is a container of key value pairs. That's how you structure a request. It turns out there are much better containers and notations for key value pairs. It provides for negotiation, which was an important thing early in the web because early browsers didn't support all of the graphics formats, all the different kinds of image files. And so being able to say, I want an image, but I can accept these formats, that was important then. Not so important now, but we still pay for that overhead on every request. And it's a request response protocol. And for me, that's the biggest problem with HTTP, because it means when you make a request, that channel is frozen until the request comes back. If the client has another thing it wants to ask for or inform, it cannot do that until the first thing is finished. So that makes it very, very inefficient. That's why browsers will often open up multiple connections to a server just so they can have several HTTP requests going on simultaneously, because the thing is so incredibly inefficient. It also makes it very difficult for the server to initiate communication. It might be the server wants to say, something has changed and you really need to know about it. There's no way it can easily tell the browser. The browser has to ask, has anything changed? So I want to fix that. DNS, the domain name system, that was originally created as a convenience so that you didn't have to remember how to type IP addresses. You just type in a name and it would do a substitution, which is great. But it overlaps with the trademark system. The DNS system did not consider trademarks, but domain names have become trademarks, and those two systems are incompatible. My big problem with DNS are its security problems. That there's DNS poisoning and other hazards where you can't really trust it to give you a good IP address, and so that is a security problem. SSL, Secure Socket Layer. This was something that Netscape came up with to allow for encryption and some level of authentication. Unfortunately, the particular scheme they came up with was very, very complicated. The most amazing thing about SSL is we still haven't gotten it working yet. It seems almost every month another major break is found in SSL. Really serious, bad stuff. I mean, we should have had it debugged by now. It's been 14 years, but we're still finding big problems with it. One of my biggest problems with it is that it is based on certificate authorities, on public key infrastructure. And the advantage of public key infrastructure is it allows for verifying certain security relationships in an offline world. But we're in an online world now, so we don't need that. We could do all this stuff online and it would be much more effective. My bigger problem with certificate authorities is that I don't trust them. The main certificate authority is VeriSign. I don't know who they are. I don't know why I should trust them. I know from looking at Wikipedia that in the past they have issued bogus certificates. And I do know that they've been hacked, and I know that they lied about being hacked, and I know that they have still not told us what actually happened, how they were compromised. So that's worrisome. More than that, there are hundreds of additional certificate authorities, many of whom have already been corrupted. that we know they've been breached, and your browser trusts all of them equally. That system makes me really nervous. It claims to be providing a security. I'm not convinced it does that at all. Then there's HTML, the hypertext markup language. Is this a good thing or a bad thing? Well, it depends on what you're trying to do. If you're trying to make simple technical documents, it's not very good. It's a very difficult thing to work in. It's a very fussy notation. There's a lot of labor in writing it. It's very difficult to get it right. That's why we invented Markdown languages. Markdown languages do what HTML was designed to do, but they're much more effective. They're much easier to use, much easier to write correctly. Now, what you want is a container for delivering applications through the network. HTML is terrible. It was not designed for that. It was designed to be the simple text document format. We have been extremely clever. You have been extremely clever in figuring out ways to make it do this thing that it was not designed to do. But I think we could do much better. One of the things that I don't like about HTML is that it encourages a style of development called templating, which you create HTML templates and then you figure out a way to inject data into those templates. I don't like templating for 3 reasons. One is it tends to create this fixation on HTML as the end product. And HTML is far from optimal as a way of creating information that we want to present to people. There are much better, more effective formats than HTML. But when you're working with templating, that's pretty much all you've got. And even worse than that, you get this tendency that at every level of the pipeline, everything is focused on ultimately producing HTML. So the thing is a trap that we'll never be able to get free of HTML because everything wants to go to HTML. It's really, really sticky. Then the biggest problem I have with it is the vector for XSS injection. And I'm really, really worried about the implications of those sorts of security problems. Templating, though, has become so popular, we're now even seeing client-side templating, which, I'm not kidding, it's now moved to the client side. It's nuts, it's everywhere. The document object model, or the DOM, is the API that the browser provides to JavaScript, and it, I think, is the worst API ever invented. It's just awful. Fortunately, we've got lots of libraries that sit on top of it and turn it into something which is much, much nicer, but still underneath, it's still the DOM, and the DOM is horrendously insecure, because if the attacker can get access to any node, it gets access to every node, because they're all linked together. So the security properties of the DOM are as bad as all of its other properties. CSS, cascading style sheets. CSS was designed for a different purpose, for the layout of technical documents. It was not designed for the kinds of things that we're doing. It's still really hard to do certain kinds of layouts and alignments because it wasn't designed to do the things that you're doing. It was designed to solve some other problem. And it does not have the modularity that we need. So it's very easy for one component which gets loaded into a page to break everything else. JavaScript is the scripting language that is in the web. It is a hot mess, but there are some good parts in it. And it requires some effort, but I think if you write just to those good parts, you can actually write good programs in this very damaged, broken, ugly, nasty, smelly language. So I'm going to keep that piece. So many people have tried to fix the web or to replace it. Microsoft, Apple, Adobe, Oracle, and many other companies have each taken many attempts at trying to capture the web or to replace the web with their own technology. And they have all failed in all of their attempts. And lots of other companies too, small ones, big ones, everybody has tried to do this. In almost every case, the technology that they were proposing was much better than the technology that the web provides. But in most of those cases, their solutions were not open because the goal was to create a new proprietary global network. I think the reason they all failed was not because they weren't open, although I think they should have been open, but because there was no transition. There was not a clear plan for how we get from where we are to where they wanted us to be. Their transition plan was mainly about trying to capture your attention, but that turns out not to be the important piece. So we need a better transition plan if we want to figure out a way to effectively fix the web. So my plan is to not try to replace the web or to capture the web. I like the web being open. I like the web doing the things that it does well, so I want to keep those with no change whatsoever. But I want to fix the things that are deeply broken, particularly with regard to security, particularly with regard to finance and things of value. So my metaphor for this transition is high-definition television. This is something that began in Japan, and then that movement migrated to the United States, where it became digital, which then moved to Europe, and then moved all over the world. So everybody has high definition now. And we got to that from a previous analog system. The analog system would send pictures as an analog waveform, which would then be captured on the other end and produced in phosphors. The digital high-definition system was completely incompatible. It was just totally incompatible. But we found a way to make it work. That we came up with a transition plan, a transition plan based on the idea of a set-top box. A set-top box was a little gadget that you could put on top of your TV, which could receive digital signals, which would turn them into analog signals so that your old analog TV could see them. And in the United States, those set-top boxes were provided free or at very low cost to poor people so that everybody would have access to the new digital TV. And it worked so well that most people who were watching were never aware at any moment of which system they were watching. Were they watching the old analog system or the old digital system? There are things that could have given them clues. For example, the digital system generally looked much better if it worked. It was less likely to work than the analog system. You could change channels faster on the analog system than you can in the digital, but otherwise they didn't know. And that was really good. The most important part of the transition plan is to bring the audience along, because there are more of them to convince than of us. So those are the people we really have to focus on. And for the digital television transition, we got that right. So I want to apply this as a metaphor to the web. And the equivalent of the set-top box of this metaphor is the helper app. Anybody remember helper apps? Some of the older guys, maybe? No? Really? Wow. So the very first generation of web browsers had a thing called a helper app. So that if you tried to open a type that it didn't recognize, like some kind of image that it didn't know, instead of giving you an error, it would open up a paint program that knew how to display that. Or if you wanted to play a sound file and the browser didn't know about sound files yet, it would open a music player and that would play it for you. And if you look deep inside the control panel of your web browser, you can still see vestiges of this stuff. It's still in there. So that's how I want to get in there. I'm building a helper app which will understand this new kind of web, which will have the new capabilities. It'll be like the digital web, compared to the present analog web. Except it's not digital analog, it's insecure and secure. But it'll give us access to the secure thing. And so anybody who's highly motivated will be able to install the helper app and be able to see it. My expectation is that virtually 0% of the world's audience is willing to do that. So we need to figure out another way to make it happen. But that's where it begins. So this is my transition plan. First, I'll make the helper app and I'll distribute it so that you can take a look at it and see if we can get anybody to agree that, yeah, this is something that we should be doing. This is the next way to go. Then I need to convince one progressive browser maker to integrate it. to build it into their browser, so it's standard equipment. So there's no installation, no clicking, it's just how it works. Auto update, next version has the helper app built in. I don't know which browser maker it'll be. Might be Mozilla. Mozilla is very often the first to do something. Good chance it might be Microsoft. I'm very impressed with the things that Microsoft has done with Microsoft Edge. They're starting to get kind of scrappy. They're really trying to get away from the Internet Explorer thing. They might want to do this. It really doesn't matter which one, I just need one. I'll then try to convince one secure site to require its customers to use that browser so that we can get to that secure feature. We just need to get one site who believes that the need for security is so important that they're willing to tell their customers, we require that you'd upgrade. I'm guessing it may start with a very high-end financial services site, but it could be anything. Then the next step is risk mitigation will compel other secure sites to do the same thing. So once they see that these guys are doing that and their customers are doing it and we're not seeing any hacking happening from them and it's a much better way of doing business, then we'll do that too. And hopefully we'll start getting a cascade of companies. All the banks, all the financial institutions, everybody will start to work on this, and then eventually major retailers and so on. And then competitive pressure will move the other browser makers to integrate the helper app too. Integrating the helper app should not be a difficult thing for them because all the helper app needs is a viewport and events and a JSON message component so that the browser and the new thing can talk to each other. That's it. So integration should be really, really easy. So I'm hoping once we demonstrate that the market wants it, it should be easy for all the browser makers to go ahead and implement it. And then the world will follow for improved security and faster application development. And nothing breaks. So I'm not proposing to change anything about how the current web breaks. I'm not proposing adding any new features to the current web because I think ultimately as we add new features to the old web, we're actually making it worse and not better. So I'm not proposing doing any of that. I'm making it another thing which will appear on the same screen as the old one. The new system will take advantage of strong cryptography. The cryptography I've listed here is much stronger than I need for this application, but I'm paranoid. And we've also seen this stuff tends to get invalidated faster than we anticipate, so I'm going to go with stuff which is really strong at this point. Even though it's strong, there's still reason to be concerned about it. For example, I'm using elliptic curve cryptography. This stuff was standardized by the National Security Agency, and we already know that they have corrupted public data processing cryptography standards in order to make it easier for them to break them. And we don't know if they've done it to this one yet. We have good reasons to think that they probably have, but we have no evidence yet, and no researchers have found any instance of it. But it's currently the best we've got, so that's where I'm going. Now, just having strong cryptography in the system is not proof that it's going to be strong. We've seen lots of cases of systems that had crypto in them which were circumvented because it turns out that key management, for example, is a much easier way to break a system than trying to break its codes. But at least we're going to start with good stuff. Zuko has a theory that in any naming system, there are 3 valuable things, and you can get at most 2 of them. The one that the web chose was human meaningful. URLs are a human meaningful representation of an address, or just barely, at least for most people. But there are big security problems with the way URLs work. We can see that they can be spoofed, they can be confused, they can be corrupted, they can be hijacked. So I'm going with the other 2 instead. So the names my system is going to use are going to be the ugliest, most horrendous names you've ever seen. But I'm confident we can make them secure, and then we can put a nice UI on top of it to keep it from getting into people's faces too much. So I'm going to be using elliptic curve 521 public keys as unique identifiers. They're going to be globally unique. They will not require any central registration. Everybody can make their own. We're going to give you a good random number generator, which will allow you to be confident that the number that you produce is going to be unique in all the world, and that will be the only thing. And having that as your unique identifier, you will not need any passwords anywhere. The way you will convince people that you're you is that you will be the only one who can decrypt things that are encrypted with your public key. Instead of using HTTP, we're going to be using secure JSON over TCP. I love TCP. TCP is great. I think it's one of the smartest things anyone has ever done. And so just put JSON on top of it and make that secure, and we're done. It's a really, really nice way of doing stuff. And again, it's a full duplex system so that you can make requests at any time. You don't have to do the request response thing. It's much more flexible. So this is what a URL will look like. And again, it's going to be the ugliest URL you can see. We're going to start with the word web, web colon. I think that's the one that the web should have taken. They didn't, so it's available, so I'm going to take it. I'm not confident I'm going to get away with this, but you know, for now, we're going to say web. The public key will be a 520-bit public key, base 32 encoded, which means it's going to be 105 digits long, which no human can type that. Well, no, that's not strictly true. So if you're in the underground, you know, here's the code, you know, I think you could do it, but it's going to be hard. You can't ask people to normally do that. Then an @, then an IP address. It's probably going to be an IP6 address, which, you know, you've got 8 3-digit things separated by colons. That's pretty nasty too. And then optionally a slash and some capability, which is just probably a secret number or code which will one time get you into something. So one way this might work is you're on my page and I want to send you to my secure site. I'll just give you this URL and you go there and we'll go. Or you might ask Google and Google will tell you this. I trust Google long before I trust VeriSign. Or it might be when you go to your bank, your banker is going to give you a card with a QR code on it and say, scan this and then destroy it. And once you've processed this, we'll integrate you into your account. And you will never use a password with that bank ever again. So there's no danger that anyone can ever trick you into giving up your password because you will not have it. The only thing someone might trick you into is giving up your private key, but that's going to be another 105-digit thing. That's not something you're going to give up easily. We'll also provide trust management to help people make good decisions about things, and all of the account and relationship information that you develop will allow you to keep it out on the web or in the cloud, and it'll always be encrypted, so we'll keep it safe. We'll also give you a pet name system so that you can give nice things to all of these terrible 105 character names so that it's easy for you to use, and it won't be spoofable because no one else needs to know what names you gave to these entities. All computation will happen in a container which is called a vat. A vat is just a big vessel with very tightly controlled inputs and outputs. I wish the word vat stood for something. It looks like it should. You know, it's a virtual something, I don't know. But it's just a thing. It's much stronger than a sandbox. The problem we've seen with sandboxes is they leak. And if you have a cat like I do, you know you don't want a sandbox that leaks. So all computation will happen in these vats. Each party will have his own vat. So my bank will have a vat, my merchant will have a vat, everybody has a different vat. The vats may be able to communicate with each other through JSON, so they can do cooperation under mutual suspicion. So if there are complex flows that we want, they can do that without any possibility of being able to corrupt each other. It means we can finally do mashups correctly, where we can have widgets representing multiple parties all running at the same time, all working cooperatively without any of them being able to correct the others. And again, this gives us cooperation under mutual suspicion, which I think is necessary for doing financial transactions on the net. So this is the block diagram for the helper app. It's really simple. They're just 2 blocks in the block diagram. The first block is a JavaScript event loop message server. Probably Node.js. I'm hoping something better will show up, but if not, Node will work just fine. I can't use it exactly like Node because Node was not designed to the security requirements that I'm working with. So there's a lot of stuff in the Node APIs that just has to be ripped out. I'm not sure I can have NPM in there because NPM allows you to run any code from anywhere that can do anything. You go, you can't do that in a secure system. You need to be smarter about that stuff. But that'll be where a lot of the application will run. It'll have access to the file system, at least limited access to the file system. It'll have access to the network. Then the other box will be Qt. Qt is a framework that was developed in Norway. It's popular in Europe, apparently. It's really nicely designed. They've got a JavaScript layer in it now called QML. It's a very, very nice way to be developing applications. So we'll run UIs in there. So in Qt, you will do the stuff that goes on the screen that interacts with the user. Everything that interacts with the server will be in the other one, and they will communicate with JSON messages back and forth. So this will solve one of the problems we have on the web, where we have serious layer confusion, where we don't have good separation for what's doing UI, what's doing model. It's kind of all over the place. In this case, it has to be well segregated because the architecture will require that. One of the things Qt will allow us to do is to have multiple components on the screen at the same time, each of them containing a program from a separate interest. And they can all be running on the same page and nothing gets amok. It's a thing that we hoped that iframes could do that they couldn't do, we'll be able to do finally in this system. So I'm proposing that we keep the old web exactly the way it is to work, exactly the way it has, to do the thing which is really good at, which is promiscuity. The web lets you go anywhere, at any time, meet anybody, and have some limited interaction with them. And that turns out to be a really good thing. We can do a lot of discovery that way on the web. Where it breaks down is when you want to have a commitment. The web was not designed for committed relationships, and for commitments, I recommend using the new system. So we use the old web to introduce us to the new web, and once it gets serious, once we're going to start pushing money around, for example, or once we're going to finally reveal our identities to each other, at that point we want to go into the committed web, where it's much safer. Eventually, I'm hoping that the old web will adopt NoScript, which is something that's been available for a long time in Firefox. NoScript allows you to control which sites are allowed to run JavaScript. I would like that to be standard equipment in every browser, because most of the time you don't want JavaScript running when you go to a page for the first time, because you don't know what's going to be happening there. And eventually, I hope that the old web will move farther and farther away from JavaScript, that all JavaScript applications will migrate into the new web instead. So there's nothing new here. There's no new technology, no new breakthroughs, no new architecture. Everything that I'm talking about here has been around for decades. It's been in the literature, we're very familiar with it. It's just we haven't figured out how to get it into the web. There have been a lot of attempts, but nothing has succeeded yet. This one, I think, may succeed because I'm starting with the transition plan. And because I'm not trying to completely fix the web itself, because ultimately I don't think the web is fixable. But I don't need to fix the whole web, I just need to make a new corner of it where we can do things safely. So in the meantime, keep doing what you're doing. Don't change anything based on what I've just told you. There used to be a practice called FUD, fear, uncertainty, and doubt. It was practiced by Microsoft and before them, IBM, with a practice called vaporware. And for example, if Control Data was announcing a new mainframe which was going to be the fastest computer in the world, and you're IBM and you don't have anything like that, how do you avoid losing sales to Control Data? What they did was said, we've got a better machine coming out, so just wait for it. And a lot of Control Data's customers did, and which meant that Control Data couldn't sell the machine. So eventually they took them to court and they won, and Control Data got millions of dollars. But these companies still do that practice. So you could look on what I just proposed to you as vaporware, because it doesn't exist. But the difference is, I'm not telling you to wait for it, I'm not asking you to change your behavior. I'm just, hope. I hope I'm offering some hope, that I think there's a way we can turn the web into a better thing, and I think that would be a better thing for all of us. So stay tuned. My plan is that not too long, and I can't say how long is, this stuff will be available to you and you can start playing with it. I can't promise that that will ever happen. I can tell you what my intentions are, but you all know that the intention of a programmer is meaningless, right? That we always intend to ship it, right? We always intended to, I don't know why it turned out, it was not in my intention. So that's where it is. So until next time, keep calm and JSON. Thank you and good night.